Good morning, good afternoon, everybody, depending on where you are in the world. Thank you for joining our webinar today for Wi-Fi 6 in the industrial automation world. My name is Justin Shade. Today we're going to go through a little bit of the details of Wi-Fi 6. Just a couple housekeeping things. This is a one-way conversation, so I won't be able to hear anything from your end. There'll be just me communicating out. As we go through the presentation, hopefully we'll be within a 30 to 45 minute range with some time for questions at the end. So if there are any questions, please use the question and answer tool in the Teams area. And we have my colleague Dan Schaefer in the chat, and he'll be answering any questions or saving them for the end to discuss after the presentation. So to get started here, just a quick intro. My name is Justin Shade. I'm the Senior Product Marketing Specialist at Phoenix Contact for our wireless products. Been with the company about 15 years, working in various areas, tech support and wireless group. I started as an apprentice here back in the early 2000s. So been with the company for a while. A little bit of background on what I've done. I've been a contributor to the NIST Industrial Wireless Technical Working Group. If you haven't read their documentation on industrial wireless, free documentation there on their website. Also had some trainings and experiences with the Certified Wireless Network Professional Group and the Wireless LAN Professionals. Again, if you haven't taken a look at their websites or their blogs or their different resources, it's very, very valuable. A lot of great information there, a lot of great networking available there as well. So a lot of information today, so I'm going to jump right in. Today's agenda, what is Wi-Fi 6 and Wi-Fi 6E? What problems we typically see in industrial automation? What are we trying to solve here? Going through a couple of new features and functions of Wi-Fi 6. And then a big question that we get is, we have these new technologies, Wi-Fi 6 and 5G coming out. Which one's better? What should I use? Why should I use it? And then I guess the big question is, when can I get it? So those are the items I plan on covering today. So to jump right in here, what is Wi-Fi 6? Wi-Fi 6 is just a name for the 6th generation of wireless LAN. So depending on what certifying body you follow, you may hear Wi-Fi 6, or you might hear 802.11ax. They are the exact same thing, just a different nomenclature. And where that comes from is the IEEE, who builds all the functional specifications for these different technologies. They've been around for a long time. They're the ones who use the nomenclatures 802.11a, b, g, n, ac, ax. The Wi-Fi Alliance is another group who works more in the enterprise consumer-based area, where they really work for making sure that all devices are compatible with all devices. So if you think about your home devices, making sure your Fios or Comcast or your ISP router can work with your Xbox and your iPhone. They're working through those things to make sure every device is compatible. And what they found is, again, at the consumer or the enterprise level, 802.11ax, a, b, g, those terminologies were really tough for people to follow. So they came up with a more of a generic way of describing what these different technologies were, which are the Wi-Fi 1, 2, 3, 4, 5, 6. So this is just a table kind of going through the equivalence of Wi-Fi 6 equals 802.11ax, and then the frequencies it runs on, and the over-the-air data rates. So that's kind of the history of it. You can find these tables online. And then what Wi-Fi 6E then is correlated to is the frequency in which the technology is using. So in a previous table, you saw 2.4 and 5 gigahertz there used across the spectrum since Wi-Fi 1 to Wi-Fi 6. And that's been the history of Wi-Fi, using 2.4 gigahertz and 5 gigahertz channels. So just at the end of last year, the FCC did grant, in the US at least, the ability for unlicensed Wi-Fi communication to start being used on the 6 gigahertz channel. So if you see the available channels here, 2.4, there are in the US 11 channels that you can use, but only 3 of them don't interfere with each other, channels 1, 6, and 11. So if you're doing Wi-Fi communication on those channels or on 2.4 gigahertz frequencies, you have 3 different channels that you can use and not interfere with each other. On the 5 gigahertz channels, depending on where you are and how you're using it, you can see you have, 4 times the amount of spectrum there across the different 5 gigahertz frequencies. The issue is we're still, finding that there's a lot of density of Wi-Fi and it's getting filled with lots of devices. So we needed more spectrum, and that's where this 6 gigahertz spectrum comes into play. As you can see, we're opening up a ton more spectrum to be used to help with channel planning, isolation of different access points in a high density area. So this would be really great for Wi-Fi design coming here in the next couple of years once the 6 gigahertz chipsets and everything are widely distributed and available. But that's what Wi-Fi 6E is. Wi-Fi 6E is the ability to use Wi-Fi 6 devices on the 6 gigahertz spectrum. So when you're talking Wi-Fi 6, and there's a lot of new features and functions coming into this technology. And again, looking back at that table back a couple of slides, you saw that Wi-Fi 6 can get up to 4.8 gigabits per second over the air. So this is all the stuff you're hearing on the TV and everything with faster, best Wi-Fi communication ever from your ISPs, doubling the speeds. But I look at those commercials, and I really go, is that really for the industrial space what's really important? At home it is, it's great. You have all these devices, you're trying to stream video, you're trying to play, doing gaming. You need those higher over-the-air data rates. But in industrial automation, what are the problems you hear? Communication is too slow. Okay, so we're not getting updates as fast as we want. I keep losing communication to my devices. There's quote unquote not enough bandwidth. So these are the things I hear day to day is, things aren't working, communication is too slow, things are timing out, I'm dropping my communication. I need more bandwidth, right? So therefore Wi-Fi 6 is going to solve all my problems because it has more bandwidth. But if you look at, the average size of typical industrial automation protocols, we're not looking at big packets. On average, if you look at a Wireshark capture of Modbus or Ethernet IP or Profinet, they fluctuate up or down, but I mean, they're not big. They're about 100 bytes. So do we really need more bandwidth? Do we need this gigabits per second data rate? I argue that it's not going to solve every problem because RF availability is the issue. With WLAN, with Wi-Fi, it's a very nice and protocol where it won't try to talk over each other. So if it hears another device talking, it doesn't try to talk over it. So if you have a high density of devices all trying to talk at the same time, they have a mechanism built in where they have to listen to see if the channel's clear. And if it's not, they have to stop, back off for a random period of time, and then try again. So in these time-sensitive applications where you're doing robotic arms or real-time control, you have to have a clear spectrum, because if your device is going to time out in 10 or 20, 30 milliseconds, one retry on that spectrum because the spectrum is busy could be enough to fault it. You're not looking to send a lot of data. You're looking to send data efficiently and reliably. So in my opinion, a lot of these issues we're coming into an industrial automation space come down to the spectrum is not clear enough for us to communicate effectively and efficiently. And that's only going to get worse as more devices are added to the factory floor, more devices become wireless. These new technologies, we don't want to run wires. We want to do these things on battery power. So, as we add more and more devices, people carrying more devices on the factory floor, that RF spectrum availability is going to be tougher. The designs are going to be harder because you're going to need to have isolation between cell to cell. And that's really where Wi-Fi 6 is going to benefit our industry a ton. So this is a laundry list of some things that are going to be coming on with Wi-Fi 6. But I'm really going to focus on 3 of these things, and all 3 of them come with spectrum efficiency. So the 3 I want to focus on today are BSS coloring, multi-user Mimo, and Ofdma, because again, all these things are going to help us communicate on the available spectrum more effectively. So first, BSS coloring. So if you look at the factory floor, you have different access points that are set up here to cover your factory floor. And typically what you have to do is you have to plan out these different access points to have different channels. So what you typically want to do is have one on channel, again, for 2.4 gigahertz, one on channel 1, one on channel 6, one on channel 11, because they don't overlap. They don't interfere with each other. But again, as you have to have more coverage, as you have to have more capacity, you have to start reusing those channels. And again, depending on how many different people are using Wi-Fi on the factory floor, that may become hard to have a clean, open channel. So what BSS coloring is going to do is provide some identification of communication on those channels. So if I have 2 access points on the factory floor, I have a station or a client or an end device that wants to talk to these 2 access points. Again, typically access point 1 will be on one channel, access point 2 will be on another channel. But if I wanted to use the same channel on both of these access points, channel 36 in the 5 gigahertz spectrum, for example, you're going to have a cell area that's going to be reliable because it's close by, that doesn't hear the other access point talking. But you're also going to have this radius where this station is going to hear communication from this access point and this access point. And if you recall again, if this access point tries to communicate and hears something else talking on the channel at the same time, it has to stop and wait and back off and retry later. So again, depending on how frequent communication is here and how much other stuff is happening on this access point, if there's a lot of communication happening really quickly, it is possible that this station will not gain access to the RF spectrum, the air, to send its data for a quote unquote long period of time. And a long period of time could be 100, 200 milliseconds. But for an industrial application that's time sensitive, that's a really long time. So what BSS coloring does is provides an identifier on that packet for the station to know if I don't see, the color yellow in communication on channel 36, I know that's not for me. I can ignore it and I can still transmit anyway. So again, it helps with identification of RF spectrum to know if I can talk, even especially if I hear communication that's not on my channel. So today, the way communication happens with 802.11n, 802.11ac, that's Wi-Fi 4 and 5, is if there's traffic from an access point client network, this other access point client network can't talk. It has to wait. So it'll sit and wait, one packet at a time. So while traffic on network B is talking, no traffic on network A can talk. As A is talking, if B needs to send, it needs to wait until it opens up. So again, this happens very quickly. Wi-Fi has been working for a long time. This works really well right now. But again, as we have more and more density on our factory floor, this is getting more crowded, and these delays happen more frequently. So with coloring, what happens is both of these networks can identify if the traffic is destined for them, and if it's not, they can still communicate simultaneously with other networks. So we'll see how this works in reality. It's really good in concept right now, and it's going to help again with reuse of channels. Especially again, you're going to have your OT world and your IT world. So you're going to have IT processes on the factory floor, you're going to have OT processes on the factory floor. So there's going to be a lot of devices there. So if we can use coloring to help identify different networks, the ability to reuse those different channels and have more density is going to be very valuable. The goal of BSS coloring is to, create more coexistence and add capacity to your factory floor. The next function is multi-user Mimo. So when 802.11n came out back in the early 2009, 2010 area, the functionality of multiple input, multiple output Mimo came into play. And what this allowed you to do is to send multiple streams of data simultaneously to a end device. And what that allowed you to do is to increase your overall over-the-air throughput to get the 300, 400, 500, 600 megabits per second that you get today with, and then technically the gigabit per second data rates with AC. But that was all to one station. So again, looking back, we just talked about BSS coloring. The Mimo was great when you're talking to one station at a time. So if this station needed to talk, all 4 of these streams from the access point would be used to talk downstream to this device only. These guys had to wait in line until this guy finished talking, and then they could talk. With multi-user Mimo, the access point is going to have the ability to now divvy up those streams based on need to those end stations. So if this station down here was a high data throughput need, so maybe it was doing some video, maybe it was doing a firmware update or a configuration download, and it needed more throughput or a real-time remote desktop, you would have the ability to allocate more of that, more of those streams to that device so that it could have more throughput. And then if maybe they were just toggling an IO point, you can use one stream and one stream to those devices, and again make the use of that RF availability more effective and more efficient. So in Wi-Fi 6, in the first release of Wi-Fi 6, downstream communication from the access point to their stations, you're going to have the ability to use this multi-user MIMO function to, again, make the use of the spectrum more efficient. Like AC and Wi-Fi 5, there are 2 releases. So the plan is to have a second wave of releases of Wi-Fi 6 that will provide you the ability to have upstream multi-user MIMO as well. So that way the stations on the remote side, if they're needing to push updates, they can, again, split up those streams and communicate simultaneously. So again, the goal of multi-user MIMO is to help increase your capacity for high bandwidth applications with larger packets. So again, if you find that need on your factory floor you need that higher throughput, this is going to help you get, again, more efficient with high throughput applications. And then the third, and in my opinion, the most exciting function that's coming with Wi-Fi 6 is going to be this Ofdma function. So again, talking about the application on the factory floor, if you have a cell here, an access point with multiple stations or clients, again, only one of these today with Wi-Fi 5 and below, only one of these devices can talk at a time, whether that's access point down to a station or client up to an access point. It's one at a time. And again, these things happen really fast, but if one device needs to talk and another's talking, it has to wait. It has to randomly back off for a random amount of time, and then again, check the spectrum again to see if it's available. If it's not, it has to wait again. So it's kind of like a sequential, again, today, OFDM, orthogonal frequency division multiplexing, which is what we use in Wi-Fi 4 and Wi-Fi 5, is a sequential type communication. Station 1 can talk, then 2, then 3, then 4, then 5. If 4 has to talk when 5 is talking, it has to wait. And this is how communication happens today. And again, it happens really well, works really well, until you have a lot of these devices. Again, a lot of this communication is really low bandwidth, small data points. So the communication from station 1 is taking up the whole spectrum, that whole channel, even though it's only sending a small bit of data. So in comes OFDMA, orthogonal frequency division multiple access. And the multiple access is the really exciting part, because instead of taking up the whole spectrum for its communication, it's only going to take up what it needs. So therefore, you can have up to 9 stations simultaneously talking at the same time. And again, think about that from a real-time data update need. Again, these communication points take very, very small amounts of time, microsecond times to get on the spectrum, get off the spectrum, get on the spectrum, get off the spectrum. But if you have a high density of devices, access points beaconing down, devices trying to send data up, other devices trying to join the network, all of that goes into place and is time on the air where other devices can't send data. So now you have these stations that divvy up the spectrum and can talk simultaneously. And the way that's done is by adding what they're calling resource units. So the access point is going to be able to divvy up the spectrum individually to each station, depending on what it needs to send. And depending on how big your channel is, you have multiple numbers of resource units. Most common in industrial applications is this 20 megahertz channel. So that's a standard channel 1, channel 2, channel 3 on 2.4. They're all 20 megahertz wide. Channel 36, channel 40, channel 44, they're all 20 megahertz wide. So if you're using a 20 megahertz wide channel, you could have 9 devices talking on one access point simultaneously. It can split up the 20 megahertz wide channel into 9 separate chunks for devices to talk at the same time. If you have a 40 megahertz wide channel, you have 18 and so forth. So the bigger the channel, again, depending on how big the communication block is, you can have more devices talking. And again, it can divvy that up depending on need. So say, you had one station that needed to talk with a big data packet. It can allocate at that time period 20 megahertz wide channel. If you have one device that has a medium data package, it can give it 8 megahertz wide, and then again divvy it up between other devices to allow more devices to talk at the same time. And this is really the huge benefit in our industrial applications because, again, data packets are really, really small the majority of the time. So allowing these updates to happen simultaneously will help us be more efficient on the spectrum. So now, OFDM, you have one device talking at a time, one after the other, in the same, so the time slot is much longer. Versus OFDMA, we can have them all on that same time slot here talking at the same time. So again, here's how communication happens today with OFDM. You have your download packet, you have a short interframe spacing packet, then you have the acknowledgement of that packet. So access point sends a packet down. There's a little bit of a buffer. That end device has to acknowledge that it got that data. Then there's this contention, and contention is, hey, I need to get back on the spectrum. Is anybody else talking? If there's not, then I can send more data. If there is, I have to wait. So over time, I can send, over this period of time, I can send to 3 different stations. With OFDMA, I can send to all 3 of those stations at the same time, and I can get a multi-user acknowledgement back from those 3 stations. So in the time I could send one packet of data to each one of these stations, I could send 2 or 3 packets down to those 3 stations in the same time. So again, I'm getting more data sent to devices more efficiently. And this is where I think is going to be this function is going to be really game changing for the factory floor, especially in applications like robotics, material handling, where you have a lot of devices that are moving and talking to access points. And they need really, really fast and efficient updates because they're doing, location and motion tracking. How fast do I need to go? Is there something in front of me? They work now, but this is going to make it more efficient and allow you to have and expand that functionality on that application. So again, these 3 functions are all about making the over-the-air communication more efficient, being able to have more capacity of devices, more density of devices, lower latencies. If you tried to put, tons of devices on the network today, you're going to have delays. You're going to have unexpected, unknowing circumstances of delays. Especially with OFDMA, that is going to fix that issue. And again, depending on what you're doing in your application, you're going to be able to have, 9 to 40 or 50 devices on one single access point, all talking simultaneously. So the efficiency of your application is going to increase. Add that on to the availability of the 6 gigahertz spectrum. We're going to have tons and tons of opportunity now to design networks to be really, really efficient, not interfere with each other. A lot of the conversations we have today with IT folk who, say we can't use Wi-Fi on the factory floor for industrial applications because we're out of spectrum. That limitation is going to go away with these new implementations coming here over the next year or so. So again, Wi-Fi 6 is going to be great because this is going to be an upgrade to your infrastructure today. So if you have customers who have, AC, Wi-Fi 5, Wi-Fi 4 devices already installed, they're all going to be compatible with each other, backwards compatible, and it's just going to be an update for Wi-Fi 6. But another question we're getting right now is, Wi-Fi 6 is great, but what about this, this hot topic of cellular 5G? Isn't that going to be, the end of Wi-Fi, because 5G is going to be great? And it depends. My personal opinion is, Wi-Fi 6 and 5G are going to really complement each other. And I think the big thing with 5G is the understanding of what 5G really means. So 5G is a technology, the 5th generation of cellular. So it's done in different release levels. So today, as we sit right now, the only thing that's widely deployed is this release 15 at the top here, which is just an enhanced mobile broadband, and this is, the cellular coverage in big cities. So, for your mobile devices. So you walk outside and you're on your cell phone. That's you're connected to the cellular network. If it says 5G, 5GE, you're on release 15 right now. You're talking to the enhanced mobile broadband function, where it's really going to be beneficial for, again, the automation industrial world is release 16 and release 17. And that's your short range, your machine type communication, your low latency applications for the plant floor. And those aren't ready yet. They're not here. The 3GPP, who is the body who goes through all the testing, at the end of 2020, just finished up release 16, the writing the standard for release 16. So as everybody knows, as you finish your technology writing for a product or a standard, there's some time before that can be turned into product. So that's kind of currently where we are. That massive machine networking, there are no products for it yet. There's prototypes. People are testing different things, seeing if it works correctly. But wide range deployment of that massive machine release 16 isn't available. And then again, what people are really waiting on, for robotic applications that really need reliable, low latency applications, is release 17. And that's really just in its infancy stage from a technical writing standpoint. The 3GPP isn't expecting to have that finished until sometime, middle of next year, 2022. So from that, that ultra reliable, low latency functionality, realistically, there's not going to be products available for that for general distribution until end of 2022, early 2023. So 5G is here in some constraint. From the factory floor for industrial automation applications, it's really not ready yet. It's getting close. We're getting there. We're getting close to that release 16 product functionality, but it's not there yet. But with those two communications, you're providing and bringing a lot of stuff to the table. One thing is spectrum. Again, the biggest issue with wireless communication in an industrial automation floor right now is available spectrum. It's the spectrum is busy. We don't have enough channels. People are using. We have IT and OT groups fighting over who can use what spectrum. Now we're going to have options. You're going to have the 5G on these different spectrums, the 700 gigahertz, and then the millimeter wave for the ultra reliable low latency for really, really short range communication. You're going to have Wi-Fi 6 on the the standard 2.4 and 5 gigahertz, but we're opening up the 6 gigahertz spectrum. No one uses a 6 gigahertz spectrum for unlicensed communication right now in the factory floor. It's not installed yet, so it's all going to be brand new and available for us to use. That's going to, again, provide more options for us. For those bandwidth rich applications, both 5G and Wi-Fi 6 are going to give you the options to have that higher bandwidth need. You have, with this more spectrum to get those higher bandwidth requirements, you need more spectrum for that access point. So, opening up that 6 gigahertz band for Wi-Fi 6 is going to allow you to have these 160 megahertz wide channel of options and availabilities for those higher bandwidth applications. And then again, higher output powers. So, cellular has always been one of those things that are used for longer range communication. You're going to have that too for, whether it's, release 615, where you're getting your mobile devices onto the cell network, whether that's public network like you use AT&T and Verizon, or in your plant. So one of the things people are doing right now is creating 5G private cells in their plants to have their own private 5G network. It's expensive right now, but people are, it's part of the future. It's one of those complementary things to Wi-Fi that we're going to have, and that way you can keep your non latency driven applications on the 5G on your private network, and keep the more latency driven things on other technologies like Wi-Fi 6 or Bluetooth. So we're getting more flexible. We're getting more options for spectrum. We're having more throughput options, and we're going to have more range. Again, flexibility and availability is going to be the key to the future of wireless communication on the plant floor. So another question we get all the time is, with 5G, it seems complicated. And right now it is. I mean, it's not a simple plug and play technology for the factory floor. You are installing a brand new infrastructure. And again, remembering what you're using it for right now is it's long distance. It's the coverage application. So hey, I have a new building here, and I need to have some kind of wireless coverage for my devices to my devices to get onto the internet. So Wi-Fi is an option. It's what we always used, right? But now you have the ability to create a private cellular network, buying spectrum from a cellular provider, and using that inside your facility. So you have to create that infrastructure with 5G devices, and they're not widely available right now for consumer or enterprise consumption. We're getting there, but it's not there right now, and it's expensive because it's all new infrastructure. Or again, Wi-Fi 6 is if you have Wi-Fi in your plant right now, it's just another upgrade point for your infrastructure. You go from Wi-Fi 4 to Wi-Fi 5, Wi-Fi 5 to Wi-Fi 6. From the infrastructure standpoint, it's really simple. But 5G will get there. In 5 or 10 years from now, when you're updating your cellular stuff, it's going to be exactly the same simple process to follow, because it'll be the same thing we've been doing for years. So the big question is, when can I get these technologies? So again, if you've watched TV, if you've followed, gone to Best Buy or any online retailer, Wi-Fi 6, you can get residential and some commercial enterprise devices today. And the big thing to understand with that is, again, the IEEE 802.11ax/Wi-Fi 6 technically has not been ratified yet as of today. It was planned to be done at the end of last year. It's pretty much done. I mean, most of the writing is done. It's just a formality of finalizing it. So the reason you can see Wi-Fi 6 devices today is because the hardware specification is done. All that's going to happen is once they release the final specification, is it'll be a software update for any changes that came to the specification. So that's why you can see, your ISP, your internet service provider, providing you a Wi-Fi 6 router, while you're seeing these Wi-Fi 6 routers on different online platforms to buy. Why you see Wi-Fi 6 coming from the enterprise vendors. It's available. The hardware's done. It's going to be a quick update to software. But in the industrial space, for all the things that we need, temperature, power, EMC, vibration, all that kind of stuff, the chipsets aren't available yet. They're coming. Phoenix Contact is evaluating some chipsets right now, but there aren't a ton on the market. And the biggest thing, and I stress this really, really strongly, is with Wi-Fi 6, the OFDMA, the BSS coloring, the multi-user Mimo, for those functions to be taken advantage of, the whole network has to be Wi-Fi 6 compatible. If you take a Wi-Fi 6 access point and you have an AC client or an N client connected to that access point, all those functions get disabled because they don't speak that language. So on that tune, client devices that support Wi-Fi 6 outside of your cell phone, your tablet, your Xbox aren't available yet. There are none. So going and trying to push for Wi-Fi or push to have Wi-Fi 6 installed today, warehouse wide or factory wide, may or may not be the best use of your time or money right now, because again, there are no industrial Wi-Fi 6 clients readily available. My opinion is by the end of this year, you'll start seeing them pop up. And once you have a cell of devices or an application that can use all Wi-Fi 6, then it's going to be hugely beneficial. But trying to mix and match Wi-Fi 5, Wi-Fi 6, and everything together, it'll work. Functionally, it will work. They're backwards compatible with each other. But getting the advantages out of that Wi-Fi 6, getting those features to be functional, you need to have a fully Wi-Fi 6 network for that to be, realized. So I would expect, again, by the end of 2021, maybe late third, fourth quarter, you're going to start seeing these different clients start popping up, different vendors. And in Wi-Fi or 5G, what can you get today? Release 15 is happening now. Again, we see it being rolled out to different big cities. You'll see that Release 15 right now. It's there. Release 16. Again, the goal is to have it. This specification was finished. So we should know more about releases of those devices probably here towards the end of 2021. Again, sometimes in industrial world things are a little slower. And then Release 17, which is going to be that ultra reliable, low latency functionality, probably not going to know too much until next year. But again, the benefit long term, these are the technologies of the future. For factory automation, Wi-Fi 6 and 5G, we shouldn't look at these two different technologies as competitors. If you do, you're going to be in opinionated fights between different people in your companies and in an industry. Looking at these as complementary to each other is really the way to look at it. 5G and Wi-Fi 6 don't use the same spectrum. They both are going to have different pluses and minuses and value propositions to them. We're really got to look at it from that perspective and make sure you're evaluating them both for installation. Biggest thing, again, in my opinion, is spectrum availability. Neither one of these technologies use the same spectrum. So it just allows you to have more isolation between networks, more density, more capacity in your facilities. So if you plan out a network that uses both 5G and Wi-Fi 6, you're going to have the ability to allow more people to do what they want on the factory floor without interfering with each other. Hey, IT function A can use this spectrum. OT function A can use that spectrum. B can use this different spectrum. And there's not going to be as much, worry about different wireless devices, interfering with each other. And that is really the huge benefit to these two new technologies, and especially that opening up the 6 gigahertz band and Wi-Fi. So again, if you haven't been paying attention to these functions released, pay attention to them. Make sure you're on the know about when different devices coming out. But again, the big important thing, especially with Wi-Fi 6, the whole network has to be Wi-Fi 6 to realize those benefits. The OFDMA, the BSS coloring, the multi-user Mimo. There are other things like one cool thing for kind of IoT battery powered things is target wait times where the devices can go to sleep. All these functions have to be, a full Wi-Fi 6 network. So with that, I hope this presentation was valuable to you. I hope there's some good information you can take back. I'm going to open it up to Dan and see if there are any questions in the chat here.
Hey, Justin, I'm not sure if you can hear me. Hopefully, yes.
Yep.
There were two that came in that one was regarding the configuration that may or may not be needed for OFDMA. And then a second asking about any other conflicting traffic that is currently licensed within that 6 gigahertz space.
Okay, so the configuration, yes. So the configuration right now for the OFDMA would be done. All that management is done by the access point. The access point is going to provide basically a trigger frame for the communication on OFDMA to help schedule out traffic. And in those trigger frames, the access point also has the ability to allow random spectrum or random resource units to be available for devices that may, associate to the network after those resource frames were allocated. So you'll have schedule for your resource units available for your standard application, and then random ones that can be assigned or available for devices that come out come online after that process is in case. I don't believe right now sorry, I haven't seen personally how that configuration is done, but it is done on the access point, and my assumption would be is it's going to be an enable versus disable with some more private functions available per vendor, how they want to do it.
And then on the spectrum question, the Uni 5 and Uni 7 sandwich the 6, and I think the 6 is the one that I called out as being already allocated for some of the satellite communications that are going out. Is there anything beyond Uni 6 that interferes with the rest of the 6 gigahertz channels available?
Yeah, so 6 gigahertz licensed band is used for some more, what's the word? Satellite communication, first responder communication. I think even in some construction and mining applications as well. And that's been a point of conversation with different industries and the FCC about interference and how opening up this spectrum to client-to-client communication is going to interfere with those licensed spectrum. So again, my opinion is, I don't feel there's definitely opportunity for interference. My feeling is that 6 gigahertz spectrum, the Wi-Fi 6E, is really going to be more in the factory floor indoor stadium application space at low powers, because of, again, what you're trying to accomplish with that new spectrum is capacity, right? The problem with Wi-Fi today is there aren't enough channels for low latency or reliable communication. So opening up those 6 gigahertz channels, albeit there's things using it today that are very time sensitive and or need what's the word? Critical, mission critical. Where I see the 6 gigahertz band really taking shape is, again, on the factory floor where there's already infrastructure there and they're just overdone with, oversaturated on the frequencies, or in high density areas like stadiums, and specifically in stadiums where they need lots and lots of channels for lots and lots of access points, but at really low powers. So I think it comes back to design. As long as people are doing their due diligence and following best practices and doing design work and doing their spectrum analyses and communicating with each other, the risk of interfering with critical infrastructure is going to be low. Is it going to be there? Absolutely. Are there going to be people a little upset with changes that may happen because there's more devices talking on the 6 gigahertz? More than likely. But it's something that's been needed in Wi-Fi for a long time, this extra spectrum, and realistically that there isn't a lot of spectrum out there that's available. So I think this is the best place they could have picked it. And again, there are going to be some conflicting opinions on that, especially with the industry that's been using this for a long time. So that was a kind of a long answer to
There was a good answer though. There was one last one that just came in, sort of a follow-up from MD Terrapin regarding the configuration. They had asked about the OFDMA config, and now they followed up with a question about configurations or lack of configuration needed for color bands and some of the other features. Is that all handled by the access point?
So that would be, again, handled by the access point. Personally, I haven't seen configuration pages, but again, knowing how different technology functions like that have been used in the past, again, AC and N, and how those different, when N came out, there were certain functions, and when AC came out, there were new, functions to that technology. My assumption would be is there would be an automatic function where the access point would just do it as it need to be, and there would be a more configuration savvy or advanced configuration where the user could go through and configure them as they needed to be. Again, just as an example, so all devices in the industrial world right now have, or from different vendors have, default roaming thresholds, and a box that tells you, how this radio is going to roam, and has different evaluations on signal to noise and signal strength and channel utilization that says, hey, I need to roam. To a standard user, they're never going to touch that, but to an advanced user, they're going to want to manipulate that a little bit, and that's my assumption on how it'll be done. And it'll be different from vendor to vendor. Phoenix Contact does roaming different than vendor B, different than vendor C, and all of them have different opinions on how it's to be done. So I would expect it'll be different from each vendor, but I assume there'll be a automatic and a advanced configuration option to that.
Good answer, Justin. Thank you. I think those are all the questions.
Great. Well, again, I appreciate you for your time today, everybody. I hope this was informational and give you some insight to what's coming here in the next 6 to 12, 18 months. If you have any questions after the seminar, you can find me on LinkedIn. You can email me at Phoenix Contact. My email is jshade@phoenixcontact.com, or any other social media platform you can find me on. This presentation will be available to you after we finish up. I'm sure we'll be reaching out to each and every one of you to thank you for attending and getting you the link to the presentation. So with that, I will let everybody go and have the nice rest of your day. Thank you.